Hello everybody, welcome to this webinar. Delighted to have you. My name is Alex Taylor. I'm delighted to be your host today. Today we'll be focusing on duplex and more specifically on Lean Duplex stainless steel for water, wastewater and biogas applications. I'm delighted to have with me to discuss this Erik Harkens. Hello, you're Head of Operational Marketing at Operam. You have over 25 years of experience in the stainless steel industry in different sales, marketing and supply chain functions. In your actual function, you're leading the commercial activities for Operam's end-user customer portfolio. Also with us today, Dr. Charles David. Hello. You lead project sales at Operam and you are involved with the commercial development of the company's special grades, including those used for water, wastewater and biogas applications. Before joining the sales team, you spent 6 years working as a researcher at Operam's Isberg Research Centre, where you prepared your PhD on the corrosion of Lean Duplex stainless steel. So welcome to both of you, the perfect people to ask my question. So I'm going to start with you, Erik. Now, before we start talking more specifically about Operam's products and applications, for those who don't necessarily know Operam very well, could we perhaps start by recalling what exactly Operam does and where it operates?
Certainly, Alex. Operam is one of the main stainless steel producers in the world, with production facilities in Europe and Brazil. We have a production capacity that goes beyond 2.5 million tons in production capacity. And we're mainly producing, let's say, flat rolled stainless, which is essentially coils, what is processed down to sheets or other products, and that is used in a wide variety of sectors in our industry. Some interesting, let's say, applications you see every day in our daily life, in our home, in our kitchens, in our bathroom, in our cars, where stainless is used. But also a significantly high number of industrial equipment are also, let's say, used for stainless. And this is, let's say, coming to sectors like oil and gas, like process industry, like food and beverage. So it's everywhere in our daily and, let's say, professional life. A part of stainless steel, we also have a production of electrical steel and nickel alloys. And all that we are serving customers, let's say, in more than 40 countries, let's say, worldwide. So we are a global player. And we are recognized by our customers for our service and our differentiated products.
So you talk about key differentiator products. What type of product are you talking about? Can you give us an example?
Well, Operam, basically we also are having in our portfolio, let's say, standard grades, but also a lot of special high value grades. And this up to a dimensional size up to 2 meter wide, which is a key differentiator for us in our industry. And of course, Operam, and also part of this, let's say, webinar, is also a major producer of duplex stainless steel. And let's call these steels now, let's say, the new generation of stainless steels that are in the market.
Okay, right. Well, before we get too far involved, we should probably take a moment to explain more precisely, especially for people like me, what duplex stainless steel is and how it differs from other types of stainless steel. Perhaps, Charles, you can provide us with some background.
Yes, of course. So duplex stainless steels, I also have some slides here. Duplex stainless steels are one of the 4 main families of stainless steels, together with austenitics, ferritics and martensitics. The main difference between duplex stainless steels and these other families is the fact that they have 2 metallurgical phases instead of only 1. That's where their name comes from actually. If you look at a duplex stainless steel using a microscope, for example, here we can see this image. This image shows the cross-section of a duplex stainless steel. You will see this layered structure which looks like a sandwich, let's say, of austenite in light gray and ferrite in dark gray. So these are the 2 phases, and when you see such a microstructure, you could think that the properties of a duplex stainless steel will be the average of these 2 materials, but actually no. It is more like a composite material, so it means that the final properties will be even higher than if you would take each one of the materials separately.
But can you explain to me how that's possible? How do you make this kind of composite microstructure? How do you do that?
Yeah, so this microstructure is generated during the solidification of the metal, actually, when it's still a liquid and it starts to crystallize to become a solid metal. But it is also the result of the other steps of the production, the manufacturing process, especially the annealing and the rolling processes. And of course, in order to obtain such a microstructure, you need a lot of know-how about the manufacturing process, but you also need a very specific chemical composition. We can see here on the right that for our standard duplex DX2205, we have more chromium than for the austenity grades, the traditional austenity grades on 316L and 304L, but you have, on the other hand, much less nickel. So here we can see that we have about half the nickel, so 5.5% for the 2205 when you compare to 10% of nickel for the 316L. And of course, what's very interesting with duplex is that you have much less nickel, but still you have a much higher corrosion resistance and about twice the mechanical strength of the austenity grades.
Right. So the point of this this webinar is to talk about not only duplexes but lean duplexes. What exactly are those?
So lean duplexes. By lean, we mean even less nickel and less molybdenum than for standard duplexes. So you can see here we have tried to position in terms of mechanical strength and corrosion resistance our lean duplexes DX2202 and DX2304 and compare them to the standard duplex DX2205, of course, but also some other grades. You can see that for example, DX2202, you have only 2.5% of nickel, which is quite low, and almost no molybdenum. And what is very interesting is that the mechanical strength remains quite high because these are lean duplexes, but they still have this duplex microstructure, so about twice the mechanical strength of the austenitics. And what's also interesting is that their corrosion resistance is, of course, not as high as the corrosion resistance of standard duplex, but it is similar or even better to the traditional austenity grade 316L. And because you have such a good corrosion resistance with such low nickel, it allows for cost reductions, of course.
Now, you've mentioned cost reductions. Obviously, it's a very important point. From what you've been explaining, it seems to me that lean duplexes require quite a complex production process in general. Together already with the high prices of raw materials, wouldn't this actually cancel out any savings gained from the reduced use of nickel and molybdenum?
Well, although the manufacturing process of these grades requires specific know-how, the lean duplexes have, as already shown by Charles, have less nickel, and so they are less affected, let's say, by the fluctuation of raw material elements, and specifically with nickel. We have here in the graph shown the evolution of the alloy surcharges over the last 2 years, and you see clearly that compared to classical 304, 316L, that the lean duplex and duplex in general are fluctuating less than, let's say, the standard grades in our portfolio, and which means also that these lean duplexes offer a kind of more stable pricing to our customers, and to particularly the customers that are active into the construction project markets, which require some kind of, let's say, price visibility and stability. And in order also to illustrate, let's say, this application, there is a picture of one of our customers using lean duplex for the manufacturing of stationary tanks, also in white material and in also in wide number of applications. And this is a customer of us called Oostwouden BV in Holland, who has used lean duplex for this kind of application, this kind of projects.
Very impressive picture indeed. Can I press you a little bit? What are we talking about in terms of final price? How much?
Well, there we could illustrate, let's say, to have a relative index compared to standard grades 304L and 316. So on the picture, And on the table, you see a relative index of 100 for 304L as a reference, expressed in euro per ton. You see clearly that the Lean Duplex is about the same price as a 316L, and as a 304L, sorry, and that it's 30% cheaper than a 316L, again expressed in euro per ton. And it's also like this, that the properties of Lean Duplex are significantly higher than 316L. So the combination, but already also as explained by Charles, that between the low cost on the one hand, the high properties on the other hand, makes that Lean Duplexes are a very, let's say, attractive alternative for water-related projects, and which have traditionally depending on, let's say, classical austenitic stainless steels.
Okay, well, Eric, as you just mentioned, water-related and biogas projects, which is, of course, the subject of today's webinar. It's a good opportunity to discuss Lean Duplex's relevance. Can you, Charles, tell us and explain to us the link between Lean Duplexes and these particular applications?
Of course. So water, wastewater, and biogas applications have in common the fact that they need equipment in different sizes, including very big tanks, silos. We have some examples here on this slide. So digesters, for example. And when you have such equipment in a project, it means very often that these equipment will represent quite a high percentage of the overall tonnage of stainless of the project. So when you can reduce the costs of the material that is used to produce such equipment, then of course you are able to reduce the overall cost of the project.
But in the end, what are the actual advantages, the key advantages of Lean Duplexes, such as, for example, DX2002?
Yeah, DX2202. So I would say there are three main advantages. The first one, because we're talking about projects, is the price stability, just like Eric just mentioned. When you have such a project, you don't want the price to change between the moment when you build up the offer and the moment when you deliver the equipment to the customer. The second aspect would be the corrosion resistance, because Lean Duplex have, let's say, a mid-range corrosion resistance, and that's exactly what this type of application needs. And the third aspect is the possibility of a thickness reduction, which means that because Lean Duplex are stronger, you are able to reduce the thickness of the sheets that you use to produce such equipment, and of course lower even more the costs.
Now, you've just mentioned corrosion resistance. Without getting too technical, so that even I can understand it, why is that so important?
So corrosion is important because it can lead to the failure of the equipment. And when we're talking about water and wastewater related projects, you can have, for example, tanks. And if there is some corrosion, they could leak, for example. We have here on this picture an example of what is called pitting corrosion. So pitting corrosion is one of the most common types of corrosion, and it happens when you have chlorides, which means seawater, marine air, brine, and it is a very localized type of corrosion, which means that you will not have the propagation of the corrosion all over the surface of the material, but it will initiate on very specific and localized spots, and then it will propagate in the depth of the material. And when you have that, you can even perforate the sheet, and then it could lead to leakages, for example. But fortunately, at operam R&D, our colleagues study this type of corrosion quite a lot using electrochemical techniques, and so we try to understand very well the resistance to pitting corrosion of our grades.
Well, how does that work? Can you explain it to me? How does that technique work to understand pitting corrosion?
Yeah, I will try to make it simple. So we see here on the right a graph have a curve actually that is the result of such electrochemical tests. And what we do is that we sweep the electrochemical potential and we check on the response, let's say, of the material in terms of electrical current. And we do that actually by putting a sample inside a water solution containing the chloride, so seawater. And when you do such a potential sweep, actually at some point you will be able, just like we see on the graph, to detect a very sharp increase of the electrical current. And when you have that, it means that the pitting corrosion initiated. So the moment when this occurs, we note that value of the potential that we call E-pit for pitting potential, and we repeat this test 12 times. And then we keep the worst value, and that is what we call the E-pit minimum that will be used later on to rank the stainless steel grades.
And how do operam's grades perform?
Okay, so we have some information here. We did this test, for example, for Lean Duplex, of course, to compare them to the austenitics, but also standard duplex. Here we have results at 35 and 50 degrees Celsius, and what we can see is that okay, the standard the standard duplex DX2205 has the highest value. Actually, for this grade, you don't even have the pitting in this environment because we reach what is called the water stability limit, so the pitting corrosion is not able to be initiated. But if we take a look at the Lean Duplexes, so the DX2202 and the DX2304, you will see that the 2304 is better than all the other grades, whatever the temperature, and that the DX2202 is at the same level of pitting resistance that the 316L at 35 degrees Celsius, whereas it is at the same level of pitting resistance that the 304L at 50 degrees Celsius. And that's a very important information because it allows us to know the limits of the material.
Now, you talked about pitting corrosion. Does that mean there are other types of corrosion? I presume so.
Of course, there are a lot of types of corrosion. We can mention another type, which is called crevice corrosion. We can see some pictures here, very impressive pictures actually, from equipment from desalination plants. This type of corrosion is also a localized corrosion. It happens when you have a very tiny and confined space, for example, behind a screw head or a bolt. And when the brine is able to go inside that space, but since you're not able to renew the environment, it will lead to a very severe type of corrosion. So that's crevice corrosion. It can happen, and that's why we also study it. And by the way, there is a very recent study funded by the European Union that tried to understand this and also understand it using Lean Duplexes.
That sounds fascinating. I'm learning so much about. What else did this study tell you?
Yeah, so this study was, as I mentioned, a study funded by the European Union. It was led by the French Corrosion Institute together with Veolia, which is one of the major players worldwide in terms of water treatment and water management. And it actually tried to assess different stainless steel grades in order to use them for the construction of wastewater plants. So I could mention one of the tests that were carried out. We can see here it was the crevice corrosion test using the CrevCore methodology. And without going too much into details, because this study is public, it was published in a scientific journal, we can see on this in this table here that because when you have a condition indicated in green, it means that that steel passed the test. When you have a red cross, it means that it failed. And when you have green and red, it partially passed. But what is important here is that the 2304 was the best grade among the Lean Duplexes and austenitics. And also very interesting is that our DX2202 had exactly the same behavior that the 316L. And that's a a very important result for us.
Now, in terms of thickness reduction, it's obviously also a key advantage because it can bring additional cost reduction, I imagine. Can you tell us about that?
Of course, that's one of the main advantages actually of Lean Duplex as well. We can see here that I was talking before about the mechanical properties of Lean Duplexes. We can see the yield strength, for example, which is a very important mechanical property of the material. For the Lean Duplexes, it will be comprised between, let's say, 530 and 550 megapascal. You can compare that to the typical value for austenitics, which is more or less 300 megapascal. So we're talking about almost twice the yield strength, and that's the value that will be used in order to know if you can reduce the thickness of the sheets or not. And so it means we can, and we have the example here of a silo filled with water. You see the design here. Previously, this type of silo was made of 304L. It needed 67 tons of 304L, and now it is made of DX2202, and it needs only 48 tons, which means 28% less material. And then you can also imagine that you will have savings with other parts of the project, such as the transportation, for example, and also the manufacturing. You could also think about the welding, for example.
Now, as you mentioned, welding, I'm sure that will interest people who are watching us, since they might be wondering if the internal processes like equipment manufacturing would change if using duplex. Can you tell us a little bit more about the welding of lean duplexes compared to traditional grades?
Yes, of course. This is a very important point because, just like you mentioned, customers want to know how the welding Lean Duplex is when compared to the austenitics. We must say that it is very easy. With Lean Duplexes, you can use any traditional welding process like TIG or laser welding. We have the examples here in this table. And the only, let's say, small adjustments that you have to make in order to weld Lean Duplex is that you have to choose the right filler metal for the welding. But the good news is that it's exactly the same filler metal that is used for a standard duplex, the X2205, which is widely available. And then the other point is that you have to have a little bit of nitrogen in the composition of the welding gases.
Why? Why should you use nitrogen?
So I was talking before about the microstructure of the duplex. Actually, when you weld the Lean Duplex, you will have a little bit more of ferrite than austenite being generated during the welding. And so when you add the nitrogen to the composition of the gas, you counterbalance that effect, and so the nitrogen allows to keep the right, let's say, austenite ratio in the microstructure. And because I'm talking about the microstructure, I would also like to say that with Lean Duplex, because some people listening to us today, they might know what the welding of super duplex is, for example. And I would like to say that there is no risk at all of generating the fragile sigma phase when welding Lean Duplex, because this is quite different from super duplex, because the acceptable range of heat input during the welding is much, much wider with Lean Duplexes, and so there is no risk of generating that phase. And I would also like to point out that it's not written here, but Lean Duplexes can easily be welded to austenitic grades. That's a very important point. There is no problem, and we're actually even carrying out a study right now together with Veolia in order to improve even more and to adapt even more our products for that, because you can imagine that you could have vessels using Lean Duplex with pipes, for example, in austenitics.
Thank you very much indeed for those insights. I think we've all understood that much better now, thanks to Charles. What are the advantages of lean duplexes? But perhaps be the opportunity for you, Eric, to tell us what are the advantages of working with operam.
Well, I would like to point out, let's say, three things regarding, let's say, these advantages working with operam. First of all, operam is for the customer a supplier of choice. As we are offering a very complete and very high value product portfolio to the marketplace. Secondly, we have a global and highly integrated service and solution network, which provides proximity to the marketplace and also proximity to the customer, which is a key element also into our strategy. And third, we also have the ability to support innovative and high-performance solution through industry-leading technical and R&D competencies, which creates and which gives added value for our customers. So these 3 points I would like to highlight as, let's say, key points for operam in terms of positioning versus, let's say, to the marketplace.
And also, in terms of operam's recent announcement about becoming the first stainless steel company to be certified by Responsible Steel, it would be fair to say also that operam offers a significant sustainability advantage.
Exactly, Alex. So sustainability is at the heart of everything that we do at operam. We not only responsibly producing solutions that are 100% recyclable, but we also have the best-in-class, let's say, CO2 footprint. And the Responsible Steel certification in that regard helps to give to our customers irrefutable proof that the stainless that they purchase has been produced in accordance with the highest standards of ESG practices, which are defined jointly between steel makers and with demanding environmental and social NGOs.
Okay, Charles, we're coming to the end. What would be your 3 or 4 takeaways from what we've discussed today?
So, about lean duplexes, DX2202 and DX2304, I think we could describe them as being the market's best low nickel corrosion resistant alloys. And then I could mention 4 key points. The first one is that they have the same resistance to localized corrosion as 316L at room temperature, or even better. The second point is that they are twice stronger than the austenitic grades. The third point is that they are up to 4 times less susceptible to fluctuations in the nickel price than 316L and 304L, as Eric explained. And finally, they are easy to weld. We just talked about that.
Okay, well, thank you both very much. I've certainly learned a lot. I hope it's been made much clearer. Thank you very much to Charles and to Eric. Obrigado and dank u wel. And thank you very much for watching, and see you soon.
Yeah.
Goodbye.